All right, welcome to my YouTube channel. I am Precious Ugweze. So, in this video, we are going to look at this other special problem, you know, under sequences. Now, it says this is an application. It says the starting salary for a particular job is $40,000 per annum. The salary increases each year by $2,500 to a maximum of $50,000. So can we interpret what we have here? So from what we are given here, it means that our beginning salary here stands for the first term, is a sequence that is increasing by this, and this one is the first term of the sequence. So it's just an addition of these two five every year. So meaning that this is the common difference. So our A here is $40,000. And then our common difference is $2,500. And from this, they said that the salary will increase to a maximum of 50,000, meaning by the time the worker begins to earn 50,000 per annum, there will be no more increase. So that is to say that the 50,000 is the last term in this particular sequence. So we have $50,000. Permit me to take away the dollars. I'll bring it back when we are done. Okay, and so the question says that we should find, the first thing here says, in what year is the maximum salary reached? So what year will this last term be achieved? And so what are you going to do here? So first of all, what it means is that you're looking for the n that will achieve this last year. You know, the n here stands for number of years. Now, but we recall that L is equal to A plus N minus 1 times D. You remember that? Okay, so, and if that is true, so we are going to have our L, which is 50,000, is equal to A, which is 40,000. Then plus N is what we are looking for, minus 1 times D, which is 2,500. And so if I take my this to this side, I'm going to have 10,000 left because it will be minus, and that will be equal to n minus 1 times 2,500. If you divide both sides by 2,500, this will take away this. So this is going to be left just with 4, and this is equal to n minus 1. And so from here, you can easily see that our n is equal to 5 if we take this minus to this side. And that's the answer. So that is to say, in the 5th year, at the beginning of the 5th year, this particular worker will start earning the maximum salary, which is $50,000. Remember that this is the A part of our question here. And so let's try to do the B somewhere here. Okay, now the B says, how much money would this person earn in that time? The time here is referring to this 5th year. So how much money would he earn in that 5th year? Okay, so recall that we're also going to make use of this data here. So the only thing is that we have found our n now to be equal to what? 5. So, and that means in this case, this person is asking you to calculate the total earnings from the first year he began to the 5th year. So in that case, the application here is just sum of the terms of a sequence. And so the question now is, how many terms are we summing? So remember our formula that Sn is equal to n over 2 into we can use A plus last term since we already know our A and our last term. You can also use 2A plus n minus 1 times D. Okay, so in this case here, we are summing for the first 5 years since the time that is being referred to here is the 5th year. So we are looking for S5, and that will be equal to 5 all over 2 multiplied by our A is 40,000 and our L is 50,000. Okay, so if you multiply that, you are going to have that this is a 5 over 2 multiplying 90,000. Okay, and when this divides this, you get 45. 45 times 5 will give us 225. Okay, so you have $225,000 as the total amount that this person would have earned in the number of years under discussion. So, and that's the solution to this problem, and which is where we're going to stop. So you see, this is one of the applications of the concept of sequences, some of terms of sequences, and all of that. So kindly subscribe to our YouTube channel, and please like, share, comment, make comments so we will know whether you're following us or not. And I also appreciate the comments I receive from people. Thank you. We'll see you in our next video. Bye.